Okay, so we've been talking about exponents, and yesterday we talked about, and briefly we had one little problem on Objective 83's notes where a negative exponent snuck in right here. And we said, look, we're going to learn more about negative exponents later. Well, that later is today. So recall what exponents mean. Exponents mean repeated multiplication. So if I say 5 to the third, it really means I'm at 5 times 5 times 5. Or if I said 5 to the seventh, it means I'm going to multiply 5 by 5 by 5 by 5, on and on until I multiplied it 7 times. But what we don't know is how do negative exponents factor into that process? So what are negative exponents? Here's what negative exponents do. When you see a number or a variable with a negative exponent, we're going to make like a fraction situation and we're going to swap it from top to bottom or bottom to top. So when you have a fraction, you have that line and it gives you a numerator and denominator. So a negative exponent, we should swap from numerator to denominator or vice versa. So if you have a negative exponent up in the numerator, what you're going to do is bring it to the denominator and make it positive. Or if it's in the denominator, we're going to bring it to the numerator. So switch from numerator to denominator, denominator to numerator. And if that doesn't seem to make sense to you, hopefully the examples will help a little bit. So the first one, you've got k to the negative 2. So here's a negative exponent, and here's what I mean. If you have a negative exponent, think fraction. I know k to the negative 2 is not a fraction, but if you put a line right there, then it's like your numerator. What you want to do is bring it down to the denominator. So k to the negative 2 is the same as, I would usually circle it and put like a little down arrow. Means it's going down. So like an elevator, bring it down to the bottom and make it k to the positive 2. And they go both ways. If you had something in the denominator with a negative exponent, you would raise it up to the numerator to change it. So using that simple thought, j to the negative 3 is going to look like what?
1 over j3.
Yeah, 1 over j3. 1 over j3. And x to the negative 4, that's going to easily turn into what?
1 over x.
1 over x. So if you're just a regular piece, like you're not in a fraction, then think your numerator. So you're going to go down to the basement. You're going to be in the denominator. Some problems on this objective are going to give you stuff in the denominator, and it's going to say, hey, rewrite this with negative exponents. So it's like it's already down there. If you raise it up to normal ground, take this h7, raise it up and make it h to the negative 7. The exact opposite. 1 over h7, if you raise that h7 up, you make it 1 over h to the negative 7. It also works if instead of h's and x's, if it was a number, like 1 over 2 squared is the same as 2 to the negative 2. All right, on this problem it says 2 over m times m times m times m. Well, that's repeated multiplication. What does m times m times m times m really mean?
M to the 4.
M to the 4th. So 2 over m is the same as 2 m to the 4th. Now if I want to write this as a negative exponent, what I'm going to do is I'm going to bring my m to the 4 up and make it m to the negative 4 along with that 2. The 2 is already up. I'm going to bring this up and make it m to the negative 4. So it's going to be 2. So that 2, and then m to the negative 4. So the 2 was already up there, and I just brought the m with the negative exponent and brought it up. Okay, we've got a handful of different examples to look at here. All right, example 1. First, write the expression in exponent form, and then write the equivalent expression with a negative exponent. So we'll probably just do this over here to the right a little bit. Just like last time, 1 over xx is the same as 1 over what?
X squared.
So 1 over x squared, that's the first part. And then the second part says, bring the x squared up and make it a negative exponent. So it's x to the negative 2. So you're looking for one that says 1 over x squared, and then that says that is the same as x to the negative 2. Next example is the same thing, except for we have a heck of a lot more q's than we have x's. I've got 5 q. That's the same as 5 over q to what power?
7.
So 5 over q7 is what we're looking for, and that happens in answer A, answer C, and answer D. But 5 over q7, we're going right to the right. This is the same as 5 over q to the 7. When you bring the q7 up, you're going to make it q to the negative 7 and just set it with the 5. So 5 over q7, if you bring it up, you'll just have the 5 q to the negative 7.
C.
So it's going to be C. They did a few things wrong on here. On A, we're bringing this up and we're just going to do q to the negative 7. That 5 doesn't have anything to do with that. And on D, they just totally lost the 5 over here. Okay, I'm pretty sure that line right there means that these are now a different type of problem. So let's see what they got. 3 to the negative 3. That should be pretty self-explanatory. 3 to the negative 3. You could just put that in the calculator. 3 to the negative 3 is 1 over 27. You see that as an option? But why? 3 to the negative 3 is the same as 1 over 3 to the third. What is 3 to the third? That's where they get the 1 over 27. So 3 to the negative 3 becomes 1 over 3 to the third, which turns into 1 over 27. Looks at 1 over k2. Write that with negative exponents. So I got 1 over k2. So I bring the k2 up and make it k to the negative 2. And then we need an equivalent expression for 7 to the negative 2 power. 7 to the negative 2 power is the same as 1 over 7 squared. And you should know that 7 squared is what?
49.
49. 1 over 7 squared. And if you don't see 1 over 7 squared, then expect to see 1 over 49. That kind of looks so weird and jagged fraction. That's it. It's like the paper got wrinkled when I copied it or something. All right, critical thinking. We've got some tough ones right here that have to do with tens. Tens always make for interesting exponents. All right, what shows the equivalent of 1 over 10 to the negative 2? So it should become, or wait, what is the equivalent for 10 to the negative 2? It should become 1 over 10 what? 1 over 10 squared. What is 10 squared? 100. So 1 over 10 squared. So we're looking for the one that gives you 1 over 100. It does that in two different spots, C and D. What do you think? Critical thinking here. C or D, C or D, C or D. I heard 2 C's and that's it.
C.
3 C's, 4 C's. Okay. What's the difference here? One's negative. You get confused when you have these negative exponents we're learning to deal with. The negative exponent, as you bring it down, doesn't make it a negative number. The only thing a negative exponent does is brings the 10 squared down to the denominator. So it's 1 over 10 squared, still positive. And then this is just the decimal form of 1 over 100. So just because you have a negative exponent doesn't make it a negative number. All it does is switch it from numerator to denominator. All right, what is the equivalent of 10 to the negative 5? 10 to the negative 5 is going to be 1 over what? Yeah, how big is 10 to the 5th? 100,000. 10 to the 5th is 100,000. So 10 to the negative 5 is the same as 1 over 10 to the 5 or 1 over 100,000. You see that twice. Which one do you think is right?
D.
D. What's wrong with B? They made a negative. Negative exponents don't make negative numbers. Negative exponents just switch the piece from the top to the bottom. And that's negative exponents for you. That's objective 84. So go ahead and get started. A lot of time to work today.